name is Lutfi, and in this video we will be talking about carbon, the backbone of life. And so these are the main subjects for this video, and so without any further ado, let's get started with our video. So living organisms, from the smallest bacteria to the biggest blue whale, are made up of chemicals that are mostly based on carbon. Okay, and you can see the carbon element in the left corner, bottom left corner. Okay, and so carbon enters the biosphere through the actions of producers. And I know you know this, but producers are organisms like plants or other photosynthetic organisms, living organisms, obviously, that use solar energy to transfer atmospheric carbon dioxide into the carbon-based molecules of life. And then consumers that are mainly herbivores or omnivores, okay, take up these molecules by eating the photosynthetic organisms. And as you might know, of all the elements in the periodic table, carbon is unbeatable in its ability to form molecules that are large, complex, and varied, making the diversity of organisms that have evolved on Earth possible. And as you might know, proteins, nucleotides, nucleic acids, and carbohydrates and lipids are all composed of carbon atoms. Carbon atoms that have bonded to one another, and atoms of other elements. Okay, and you can see these some pictures that are showing all of these proteins, nucleic acids, and blah blah blah. Okay, so you can see the carbon which is shown by C in these structures. Okay, and so hydrogen, oxygen, nitrogen, sulfur, and phosphate, these elements are other common ingredients of these compounds, but it's carbon that creates the diversity of biological molecules that we see and use all around us. So now let's get more in depth and talk about organic chemistry. So what is organic chemistry exactly? Let's start with its name. So for historical reasons, compounds that contain carbon in their structure are said to be organic molecules. And I know this definition is not very accurate, and I will be telling you a better definition in a couple of minutes. And so the study of these molecules is called organic chemistry, and these organic molecules are made by living organisms. Okay, besides being produced in labs. Okay, so yeah, they are mostly produced by living organisms. Okay, so now I'm going to talk a little about the history of organic chemistry. Okay, so by the 18th century, chemists had learned to make simple compounds in the lab by combining elements in the right conditions, and in that time, artificially synthesizing the complex molecules that were extracted from living matter, or the same organic molecules that we were talking about seemed impossible. And the interesting thing is that in those times, scientists thought that organic compounds arose only in living organisms, and that they contained life force beyond the jurisdictions of physics, physical and chemical laws. Okay, and I really respect their thoughts and ideas, but they were really wrong. And then suddenly everything changed when scientists learned to synthesize organic compounds in the lab. Okay, so how did this happen? So it was in the year 1828, which a German chemist named Friedrich Wöhler was trying to make an inorganic salt called ammonia cyanate by mixing solutions of ammonium ions and cyanate ions. Okay, and then Wöhler was astonished that he had made urea instead of ammonia cyanate. Okay, and as you might know, urea is an organic compound that is present in the urine of animals and mostly in the urine of mammals. And from that moment on, more and more molecules that were thought to form inside living matter only were produced in labs, and after that organic chemistry was redefined as the study of carbon-based compounds regardless of their origin. And have in mind that we have some exceptions to this law, to this definition, but the number of exceptions are just a few. Okay, so that was all for this video, and I hope you enjoyed it. And so, as always, until the next video, happy learnings to you all.